Hi everyone, we're going to solve word problems by using systems. These are typical problems that you see, and I try to do a variety of them. There are 5 of them together, so you can get a general idea of how to work these. In this case, we have Steve has twice as much money as Jessica. Together they have $36, so how much money do they have? Well, the first thing we want to know is that Steve has twice as much as Jessica. So if you want, let's go ahead and assign some variables here. You can use S and J. I usually do that, but to be professional, let's let X equal Steve's money. So that's what we're looking for. And Y equal Jessica's money. And then we're going to write out the system. So Steve's money, which is X, has, that means equals, twice Jessica's, so 2 times Y. Together, it means we add them together. Steve's money plus Jessica's equals 36. So since you see something like this, we're just going to use substitution. I'm going to plug in the 2y here, and I get 2 into this x. 2y plus y equals 36. So 3y equals 36, so y is 12. So that is Jessica's money. So Jessica should have $12. And to find Steve's, we just plug this back in to this y, or this one. I prefer doing this one. And 2 times 12 is 24. So X is 24. That's Steve's money. And Jessica's money is $12. And it does make sense. Steve has twice as much money as Jessica. Okay, the next one we have is about dollar bills and $5 bills. There's also things with cents. I should do one of those, basically. So basically we have a line that has our money line and our number line. So basically I'm going to let X be the number of $1 bills, and Y is the number of $5 bills. Okay, so $5. You can see the dollar. That's a dollar. Okay, so basically the total, I'm going to let the total number of bills. So this is your number line. Your number line. Your total of bills is 60. Now when you're doing the dollar amount, it's $1 times X plus $5 times Y. So these are your dollar amounts. And you should always be able to put dollar signs here, is $2.28. Now, what I'm going to do is use elimination. And actually, I'm just going to subtract here. So you're supposed to add, I'm going to subtract. So you're going to get 5y. That eliminates our x. So you get 4y equals 168. So y equals 42. And then I plug in the 42 back. I'm going to plug it back into this y. And so that means that my X has to be 18. So I have 18 $1 bills. And I have 42 $5 bills. And you can plug them back in to see if it makes sense for you. Okay. Now, this is one of those problems that it's flying against the wind, flying with the wind. So flying with the wind, we have 60 miles per hour. Flying against the wind, it's 500 miles per hour. So basically, we're going to let X equal the airplane speed, and Y equal the wind speed. So basically what you're going to do is you're going to get your airplane speed and going with the wind. So plus y equals 600. And your airplane speed and going against the wind equals 500. And then all we're going to do is add this up. We get 2x equals 1100. So x equals 550. So if the airplane speed is 550 kilometers per hour, I'm just going to plug this 550 back in, and I'm going to get 50 equals the airplane speed, which is, or the wind speed, sorry, is kilometers per hour. So again, this is the airplane speed. And this is your wind speed. So that's kind of how against the current with the current works. Okay, the next one is if 2 hamburgers and 1 hot dog cost this much money, $4.82, and the same price, 1 hamburger and 2 hot dogs cost $3.70. So how much does each cost? In this case, they're kind of like the same thing. We don't have separate lines for anything separate. We just have, I'm going to let X be hamburgers and let Y be hot dogs. So 2 hamburgers and 1 hot dog is $4.82. And 1 hamburger and 2 hot dogs is $3.70. And what I'm going to do here is elimination. So, or I could just solve. I'll just solve for Y. Since this Y is separate, I'm just going to solve for Y. So we have Y equals negative 2x plus 482. Now I substitute this in to the Y, and I'm going to get x plus 2 times negative 2x plus 4.82 equals 3.70. And that's going to give me x plus minus 4x plus 964 equals 370, which means negative 3x equals negative 594. And you divide by negative 3, you get x equals $1.98. So if x is $1.98, I'm going to plug that in. I'm going to substitute it in equation 1. So we have 2. I'm going to stick it here because I already have a word problem on the next page. 2 times 1.98 plus y equals 482. And so y equals 4.82 minus 2 times that. So basically minus 2 times 1.98. So y is 86 cents. So the hot dogs are 86 cents. The hamburgers are $1.98, which is pretty cheap. All right. The last one I have is a teacher distributing a box of pencils to her students. If each student receives 5 pencils, there are 15 pencils left. So this is going to be our first equation. If a student receives 6 pencils, there's 22 pencils short. So this is going to be our second one. And we want to let x equal the number of students. So I want to know how many. And y equal the number of pencils. So basically, for the 15 left, we have y. Each student gets 15 pencils, so that's going to be y minus 5x, because each student gets that. So the pencils minus, the total pencils minus how many they get, leaves you 15. Because they're taking away the 5 times the x. Now, however, on the second one, if each student receives 6 pencils, so each student is 6x, 6x, then they're short the pencil, so that's minus y, and they're short by 22. So I'm going to rewrite this equation, and I'm going to write this as negative 5x plus y equals 15, and 6x minus y equals 22. So when I solve for this, I get x equals 37. So that means the number of students is 37. If the number of students is 37, I plug that back in. So y minus 5 times 37 equals 15. So y minus 185 equals 15. So therefore y equals 200. There's 200 pencils, and there's 37 students. And that's a general idea of some word problems that you use with systems.